Okay, I think we are good to go. So, good evening everyone. Welcome to class 11 tutorial session of problem solving through C programming language. So, in today's class, we will be learning about, my intuition is not about teaching again Lagrangian and trapezoidal. So, we will try to learn some basic math, and then we will try to understand how programmatically we will write the code, and how we will evaluate, whether our program is working fine or not. Then I will jump into the recursion. So there are two kinds of recursion, which is linear recursion and tree based recursion. So I think I thought of covering this thing in this class only, and probably then towards the end I will try to cover what is structures and unions, and what is the subtle difference between structures and unions with an example, and then we will try to we will try to take some sample quiz, and then we will wind up this class. So this is the high level agenda for today's class. So mostly in today's class I will be shifting to whiteboard. So I will share the screen, and please do let me know if you have any issue in reading the font size or any issues. You just let me know. So let me share my whiteboard with you. Okay, so I think you are able to see, right? So are you guys able to see the screen? Yes. Okay. Okay, cool. So we will try to understand what is the intuition behind Lagrangian. So let's say if you have some points, and you don't know what is the curve or line which fits that thing. So you just need x0, and you know that f of x0, and x1 and f of x1, x2 and f of x2. So you just know these points, and in order to find out, let's say if some point is there in between x1 and x2, and you want to find out what is the output of this particular point. So if you know the line or curve, then you can easily find out what is the corresponding f of x1 for that particular x cap. But since we don't know this, so initially what we will do is we will try to fit a equation and then try to reduce the error. That is first method. But apart from that, Lagrangian proposed a theorem to come up with a curve, or quadratic curve or equation or line to fit this particular point. So this is a near approximation to the actual curve. So this is called as Lagrangian interpolation. So interpolation in the sense, if you are trying to find out a point which is there in between these 2 points, so that is called as interpolation. So if you are trying to find out a point which is apart from this point, so let's say it is x4, so it is not there in the given thing, but you are trying to find out what will be the value corresponding f of x4 value for the respected x4. So that is called as extrapolation. So within the boundary, if you are trying to find out the thing, that is called as interpolation, and apart from the boundary, so that is called as an extrapolation. So this for this extrapolation, Lagrangian proposed an equation. So we will try to solve that equation. So with an example, so let's say the Lagrangian equation to find out the corresponding curve is, so let's say let me try to undo this. So you have x naught equal to 1 and f of x not equal to 1, x1 equal to 2, f of x1 equal to 8, x2 equal to 3 and f of x2 equal to 27. So by seeing this you know that this is x cube, right? But we will try to find out the Lagrangian equation for this particular data. So first we will take f of x naught into, so you need to make sure that you leave the x1, so x minus of x1 into, next time we will try to avoid this one, so x minus x naught by x1 minus x naught into x minus x2 by x1 minus x2 plus f of x2 into, so this time we will try to make sure we don't touch this point, so x minus x naught by x2 minus x naught into x minus x1 by x2 minus x1. So now we will try to substitute these values here, 1 into x minus 2 by 1 minus 2, x minus 3 by 1 minus 3 plus 8 into x minus 1 by 2 minus 1, x minus 3 by 2 minus 3 plus 27 into x minus 1 by 3 minus 1, x minus 2 by 3 minus 2. So then we will try to solve this particular equation. So 1 minus 2 is minus, so x minus 2 to x minus 3 by minus 2 plus 8 into x minus 1, x minus 3, 2 minus 1 is 1 and 2 minus 3 is minus 1, so plus 27 into x minus 1 by 2 into x minus 2 by 1. So this, both these things will get cancelled, so we will try to take the LCM here, so 2 minus 1 2, so 2 is the LCM, so then x minus 2 into x minus 3 minus 16 into x minus 1 x minus 3, so because I just did 2 times 8, that is 16, so I have written directly, plus 27 into x minus 1 x minus 2. So now we will try to solve this, so x square minus 5x plus 6 minus 16x square plus 64x, okay, 64x plus 3 ones are 3, then 16 to 3 48, then plus 27 x square minus 81x plus 54 whole divided by 2. So we will try to reduce, so what will be the x square minus 16x plus 27x, so what will be the output, so it will be it is like 15 plus, okay, then it is 12x square minus, oh, somebody is there, so 12x square minus what with this one 64 minus 81 minus 5, it is 22x plus 6 48 54 plus 6, so it is 12 by 2. So we will try to take the common values, 2 into 6x square minus 11x plus 6 by 2, 2 will get cancelled, and 6x square minus 11x plus 6. So this is the final Lagrangian equations that we got. So, but you know that this is the actual output, right? So this is the actual curve that fits that thing. So let us try to consider we are trying to find out an interpolation for this this particular f of, you know, we will try to find out an interpolation for this this one. Okay, sorry, I muted my son. So we f of x3 equal to 4. Let us consider 4. We will try to fit. So what is actual value is 64, right? So then we will try to fit it here. So 4 in 6 into 4 square minus 11 into 4 plus 6. So 60 into 16 minus 44 plus 6, it is around 58. So this is the actual equation that we got from the interpolation of Lagrangian equation. This is the output that we got, and the actual output is 64. So you know, you will get some error, but this is the closest approximation that you can say. So there are some other methods also in mathematics, you can learn about that more, but this is how the Lagrangian equation can be solved. So each term, this is called as Lagrangian. So this is called L of x0, L of x1, and L of this is L of x2. Okay, so this is how we calculate the Lagrangian. Now we will try to understand how we will do the exact thing on the programming language, in terms of programming language. So yeah, Arshad, you raised a hand. For negative values also you can try. So you can use the formula and figure out, and then you will get the value. Okay, so let's try to let us try to share the entire screen, and I would like to explain this example. So let us consider this program. So I just wrote the same logic here what I have written. So here initially we are reading the numbers in x, y. So x naught values will be read and scanned through in this particular array, scanned in this particular array. F of x1, f of x2, and f of x3 values will be, okay, somebody is here. Okay, f of x1 and f of x2 will be calculated here, and then we will try to calculate the Lagrangian interpolation. So in the for loop we will repeat for we will ask that interpolation point for the user, and after that we will calculate the Lagrangian interpolation. Every time we will ignore the particular respected x naught. So if you are calculating Lagrangian interpolation for x naught, so you will exclude x naught and you do the calculation with the remaining two terms. And here p represents initially what we are trying to do, this is more or less like a same logic. So x p minus xj divided by xi minus xj. So the p will be changing. So L0, L1, L2, the p value will be changing. Finally we will be adding that value to yp to update the value. So this is more or less the logic of this particular code. We don't need to worry about it. Just we will try to see lang. Let me try to make this one up. So don't worry, I will paste this code in your notebook, so you can in your leisure time you can run this and check this several times and take your own time to understand the logic. So clang -o clang -o. So number of data. So I will we will try to calculate for the same thing, same example. So I am saying that 3. So x1 is 1, y1 is f of x1, that is 1, and x2 is 2, f of x2 is 8, x3 is 3 and f of x3 is 27. So what is the interpolation point? So we will say that interpolation point is 4 because we did the same example. So you can see that interpolated value. So it automatically calculated the behind the logic by using this Lagrangian interpolation, and then sum those values together in the form of yp, and finally we are printing the yp value, which is equal to 58. So this is how more or less we do the Lagrangian interpolation, and that is the logic for that code. So next thing I would like to share about let me try to okay. Okay, so now we will learn about the second one, what that is called as trapezoidal rule. So this is fundamentally the easiest one. You don't need to. So let's say you have a curve and you try to find out the areas between the curve. So initially when there is no formulas, like Greeks and Egyptians used to do this thing. So if they want to calculate the area, so right now you know that area of circle is pi r square, and volume of cube and all this stuff right now, because you derivated the formulas and everything at the hand. But when that time there is no when there is no formula, so how they will do is they will try to divide this circle into very small parts, and they will try to add those things. So they will calculate the area. So this is how the what is the origin for integration. So here what we are trying to do is, like, let's say there is a curve and we are trying to find out the area under the curve in between two limits. So this is called as f of x integration a. So this is what is the area of the curve, that function in between these 2 points. So this is the high level idea. So in order to solve this, there are so many methods, and one of the method is trapezoidal rule. So the idea behind the trapezoidal rule is that you try to, let's say you have a curve, you try to fit several trapezoids here. So initially they fit only one trapezoidal. Let's say if you fit only one trapezoidal, so there will be some error, and you will get some error. So what they got to know is, if you try to, let's say it's free, so if you try to make it into n parts, so you will have a chance of reducing the error. So that's what they came to know, and that's why they divided the a and b between among n parts, and then they try to calculate the area for each trapezoid, and finally so that the error will be reduced. So this is the high level idea of the trapezoidal. So for that, what they have done is, f of x in terms of a and in between a and b is almost identical to area of trapezoid. So area of trapezoid is half into f of a plus f of b into height. So height is b minus a. So this is the height. So this is the height. So what they came up to know is b minus a by 2 into f of a plus f of b. But if you know that you this is for single one. So if you want to calculate and divide it into multiple ways, then what they have done is, so there will be 2 times. So this limit will be coming 2 times, this limit will be coming 2 times, this side will be calculated 2 times, right? So the final formula for this multi trapezoid kind of area calculation is b minus a by this is what I inferred from the search note. So b minus a by 2n into f of a plus f of b plus 2 into sum of I to 1 to n f of a plus in. So this a plus in represents all these points, and f of a and f of b is same. So this is how we fundamentally calculate the area under the curve using the trapezoid rule. So my interest is not about teaching the math. So if we try to, let's say if you take one single trapezoid, let's say if you divide it into 2 trapezoids, 3 trapezoids, so how this error will be reduced in terms while you are programming, you need to understand this one. So I want to show the example with, let's say initially we will have a curve that is 0 to 1 1 by 1 plus x square. So and we will calculate the limit in between 0 and 1. What we will try to do is we will try to initially take 2 trapezoids, then we will try to take 4 trapezoids, then we will try to take 6 trapezoids, and we will try to take 8, 10, 20. Then we will see how the error will be reduced. So why this is I mean we will try to see this in action. So that's what I intended to do. So let me shift back to my Visual Studio. So yeah, Arshad. So let me take all these questions towards the end. So maybe you are asking the questions in break. So let me try to finish this one, then we will talk about this. So okay, whole screen is shared. So let me open this code. So we will try to in this code, so we define, this is a preprocessor directive, we define the f of x. So before that I want to show you one more thing. So okay, so as I said earlier, so we are trying to calculate the graph for, I mean limits for 0 to 1 1 by 1 plus x square. So this is what the thing which we are doing. So actual integration value of this one is around 0.7853 98 or something. So this is 7853. So just remember the 6 letters 785398. So then we will see it in the action. So the same function which I am trying to define it here, 1 by 1 plus x square. Who is Mark's call? I don't think he is legitimate. Who is Mark Call? Okay, so we will try to let me go back to my Visual Studio. So we will try to read the lower limit and upper limit of this particular thing, and then we will read number of subintervals. So that means how many times we want to break that particular thing, particular curve in terms of trapezoid. So we will find out the step size. So that is b minus a by n. So this is called step size. Then we will calculate f of lower and f of upper. That means f of a plus f of b. And then this particular thing, this particular for loop will calculate the 2 into sigmoid of 1 to n f of a plus in. So this will calculate that one, and finally that will be added to the integration part. So integration in the sense initially f of a plus f of b. So f of a plus f of b and 2 into sigmoid of f of a plus in. So this is the logic of the code, and then that value will be, final integration value will be returned. So let me clear the screen and compile the output. clang hyphen o trape, so dot slash trape. So initially what I will do is I will take only 2 trapezoids, then I will slowly increase the number and you will see the the difference. So we all know that the value of this particular thing is, approximation is 150. So let me copy paste this one here. So initially I am saying that 0 and upper limit will be 1 and sub intervals will be 2. You can see that there is a lot of large error between this expected value and the actual value. And let us try with increasing the trapezoid. So 0 and upper limit is 1 and sub intervals will be 4. You can see that the significant improvement, but still there is a error is there. So we will try with 10 this time. Sub intervals will be 10. So you can see that 7849. So if you try to do the same thing with 20 trapezoids, you can see that 7852. So it is almost equivalent. So if you try to, so 7853, so it is almost equivalent up to 4 decimal points. So that is what I want to infer. So we have seen this thing in theory and now we have seen the same thing in terms of programming language. So I will copy paste the same program in your notes as well. So try to just take a look and understand how it will work. So this is what all I want to talk about this trapezoidal rule and the Lagrangian. Now we will go back to the another topic called recursion. So in previous classes also we have used this recursion couple of times, and we all know that the recursion is fundamentally means that calling a function by itself. So this is called as recursion. So this will be used in the real time to optimize the code, and you will try to reduce your number of lines of code, and which will make your program much more effective in terms of understanding and readability. So that is the use case of the recursion. So you know that calling a function by itself. So here you can see that the function will be there, and inside the definition we will be calling that function again. So that is the fundamental idea behind the recursion. And there are broadly 2 kinds of recursion. So one is called as linear recursion and another one is called as tree recursion. So the idea behind the linear recursion is when the function is called by itself in the one time, that is called as linear recursion. So let us consider this program. So we are trying to calculate the factorial of this particular number, and during this particular logic of this factorial, so if the number is less than 0, then we will stop here. So during the execution of this program, this particular factorial will be called by itself, fact of n minus 1 one time. So this is called as linear recursion. And let's say if it is if you enter the 5, so you will be getting 5 4 3 2 1. So 5 into 4 into 3 into 2 into 1. So eventually you will get 120. So this is the example for linear recursion. So the program trace will be like this. Initially from the main, factorial of 5 will be called, and 5 will be triggering the another factorial here, which will be factorial of n in factorial function f equal to n into factorial of n minus 1, right? So initially 5 will be there, 5 into factorial of 4. So factorial of 4 will again trigger another function, and it will be going on this like a chain, and whenever it reaches to the condition factorial of 1, so again it will trace back to the function call, and finally you will get to know the final value, such as 5 into 4 into 3 into 2 into 1. So here one thing you need to understand is whenever the function is called, let's say this function is executing, and in between there is some another function call, so all these program status will be pushed into stack and the next program will be executed. So this is how typically the operating systems will work. So if you know any operating system, the program, if you try to run a program, it will not there in the main memory, or it will not there, it will be not running on the CPU for all time. So it will be there in the CPU for some time. Whenever it gets some priority works will come, so this will be put aside and that particular program will be executed, and after that this will be resumed its working. So the key thing that you need to understand here is whenever some function call or interrupt is happening, so this is a good example to explain you. Whenever you type a keyboard on your computer, so each key press will trigger a interrupt. So that's why whenever you are using notepad, so whenever you press a key on the keyboard, so interrupt will be called, so it will hold the CPU for some time, and initially it will the interrupt handler will be executed by the operating system, and that particular key will be converted from your K to ASCII number, and that particular value will be printed on the screen, and again it will resume the execution. So this is how the typically the programs also will be executed. But the thing is, you need to make sure that you need to understand one thing is that whenever there is some program call in between, the program is calling some other function, so this will be pushed into some stack or memory location, freezed, and that particular thing will be executed, and again it will come back. So the idea of this linear recursion is that we have executed this particular call one time in the program, so that is called as linear recursion. So there is another kind of recursion called tree recursion. So the fundamental idea here is that the function calls itself is a recursion function. If it calls itself more than one time, then it is called as tree recursion. So let us consider this program. So it is a void function. So this is a function which will take input as n as a parameter, and it will call the function two times during its execution. So there will be subsequent function calls. So what happens here is the interesting thing that we need to understand here. So let us consider this program int main, and we are calling a function called tree recursion of x. So the tree recursion will be printing the value if n greater than or equal to 0, otherwise it will call itself two times with tree recursion of n minus 1 and n minus 1. So I would like to trace this example on a screen. So let me try to share my screen here. So let me try to okay. So let me try to write the function here for you. Tree if n greater than 0, then we will print and so I am just calling this tree recursion as tr for simple term, tr of n minus 1, tr of n minus 1, So here it's called it happened. So recursion happened 2 times. This is called as tree recursion. So now we will try to understand what happens if the x value is 3. So that's what we are writing in the program. So initially I will take t r of 3 here. So assume that I have a stack. Whenever I got a function call in between, one function is from the main, I am jumping into another function without executing that function, I will be pushing that function to the stack, right? And then this is the output console, assume. So we will try to trace this program. Assume it is tr of 3. So initially tr of 3 will come here, and n equal to 3, so which is greater than 0, then it will print 3 here, okay, 3 here, and there will be tr of n minus 1 and tr of n minus 1. So there will be one tr of 2 here, and there will be another tr of 2. So we are not executing that particular thing here. So we will first go through this tr of 2. So then we will keep this tr of 2 in the stack, because I think somebody has unmuted. Can you please try to mute yourself? Okay, so tr of 2 will be here. So next, one tr of 2 we are trying to execute, another one we put it in the stack, right? So next, the tr of 2 will come here. Initially n will be 2, so n is greater than 2, so 2 will be printed. Okay, again it will come here, and it will after printing n, there will be tr of n minus 1, 2 minus 1, which is equal to 1, tr of 1, and there will be another tr of 1. So I am not executing it, so I will keep it in the stack. So again tr of 1 will be executed here. So it will come to here, and it will check whether it is greater than 0 or not. So it is 0, it is greater than 0, so it will be printing 1 here, and it will go to tr of 0. Okay, so now we are at the tr of 0. So tr of 0, then one tr of 0 will be here, and another tr of 0 will be there. Okay, so now tr of 0 is failing this condition, so it will say, okay, I am done with here, I will come back here. So it will, okay, let me try to, I don't want to make this look like a function call. So this will be tr of 0. So again it will come at tr of 1. So at the tr of 1, we only executed one tr of 0. There will be another tr of 0. So we will pop this one out, and we will execute it here, tr of 0. So tr of 0 again has nothing to do here, because it is failing this condition. So it will print nothing on the console output, and it will come back here. So there is no tr of 0 now here. So tr of, at the tr of 1, we don't have to do anything. So it will trace back to tr of 2. So at tr of 2, we only executed one tr of 1. There will be another function. So we will pop this one out and add it as a branch, tr of 1, tr of 1, and again at the tr of 1, so this is greater than 0, right? So it will again, so tr of 2, tr of 1, right? Tr of 1, again tr of 1 will come here, and it will print another 1 here. So it will come to tr of 0. So there will be another tr of 0 here. Okay, so tr of 0 is here. So there will be nothing printed here. It will come back here, because we don't have, this condition will fail. So we have pushed another one, we executed one tr of 0, and there will be another tr of 0. So we will create another tr of 0 here. Okay, so here also we don't have to do anything. So it will come back here. So tr of 1 is done here. So it will say that okay, I am done here, there is nothing to do. So it will trace back to TRF2. So at TRF2 there is no TRF1 present here, then it will go to TRF3. So the TRF3 has one TRF2, so it will pop out the TRF2 here, and see the TRF2 is same here. So again it will try to print 2, and then it will say TRF1, and again it will say, so TRF1 means again it will print. So that same left tree what happened here will be coming here as well. So TRF1 and TRF0. Okay, so again there is nothing to print here, so it will come and pop out another TRF0. So TRF0, so it will come back here, and again it will come back here, and there will be, so there will be two TRF1. So one TRF1 is executed, so another TRF1 will be there. So it will spawn again TRF0, so it will print 1, another TRF0, it will come back here, it will come back here, it don't have anything to do, and finally it will come back here and stop the execution. So this is how the tree recursion will be. So the final output will be 3211211. So the idea here is that so this is more or less the fancy term for what happens at the, when you call a function, by itself more than one time from a same logic, what happens. So this is how the compiler will trace the program. So this is called as a tree recursion. So what I suggest you is to do is, for the same example, try to trace for x equal to 4 and do this as an example homework, and I hope you understand this concept, right? So if anybody has any question, then I am okay to answer, because this is bit tricky to understand. So everybody got it?
Sir, why TR0 is not is given in the output as 0?
Yeah, because this, if n greater than 0, then only this condition will execute. So if n is 0, it is not greater than or equal to 0, this is greater than 0, right? So
So, sir, why that it is happening that after the value of 3, all the numbers of TR are represented 2 times. TR2 is also 2 times. Then further they are into 2
so you have you have
TR2.
called you have called this function 2 times, right? So one will be executed. So let's say, let us consider tr of 3. Your name is Tushar, right? So let us consider tr of 3 only, we will not go deep. So this is the empty stack, right? So when it comes to tr of 3, so n is greater than 0, so it will print 3. Okay, then it will go to tr of n minus 1. N minus 1 is tr of 2, right? So there will be another tr of 2. So it can't execute two programs at the same time, so it will keep one thing in stack, tr of 2, right? And it will go to it will start executing tr of 2 first. So from tr of 2 it will come to tr of 1. Okay, it will print 2 and it will go to tr of 1. So there will be, if in tr of 2 it is n greater than or equal to, there will be two tr of 1s. So one tr of 1 it will execute here, and another tr of 1 it will put it in stack. Okay, the moment it executes every node in the child, it will come back here and it will check that okay, I need to execute another tr of 1. So then it will create another branch. So the branch which I am creating here is for example. So this is how the trace will be there for the function call execution, right? So So it will come here and say that okay, the execution will be there, so there will be another tr of 0. Okay, I will execute this program and it will come here. So it will, when it comes here, it will remember that okay, I have only executed one tr of 1, there is another tr of 1 which is there in the stack, so I need to pop this one out and execute it. Got it? So it will create another tr of 1 here and it will execute it. That's why you will see 3211 as a final output. So this is how the function calls will be. Got it?
Sir, why TR3 is not repeated two times? That where is x used in the code? X is equal to 3, and you are
No,
representing in the line that is
no,
stack.
n equal to 3. So n equal to 3 and initially tr of 3 will be executed. So there will be no tr of 3 will be not called twice because only that one is calling the function. So tr of 3 is calling tr of 2 and 2 times. Okay, each one will be calling tr of 1 2 times. So there will be no tr of 3 is not called 2 times. So this is called from the main function. Main will be calling this tr of 3. So that's why 3 will be once, 211 will be there. So
Sir,
this
in the box type, the lines you are representing, that is stack overflow.
what?
In the boxes you are by line representing TR2, 1, 3, and you have cut it in the previous diagram. So they are stacks.
No, this is the process memory state. So for just for example, for your better understanding, I have represented in the stack. Okay, but usually in the program, in the system also, so whenever one program is there and if we want to execute another program, this program status will be pushed into the place and it will be there, and on top of which the next program status will be there and the final one will be popped out first and executed. So this is how the last in first out. Got it? So that is the stack implementation. That is how it will be working. Got it?
Sir, in TRF matlab tree recursion family or function.
Yeah, this is the example function. So I want to say that how
Base recursion,
recursion will work if you call
repetition of function.
function by itself more than one time. So such a kind of thing, it is also similar to the normal recursion. So but the thing here is that, so whenever you call it for multiple times, so it will create a it will execute like in such a way that it will represent a tree. So that's why it's called as tree recursion. Got it? You don't
Sir,
need to,
so
you
it
don't.
is like for else if f of function.
Okay. Anyway, I think you revisit this one again, and I think I have given a detailed you know detailed example for each and every step that I have done here, step 1, step 2, step 3 over here in the notes. So you take that. Are you guys able to see my screen? Okay, so I have given a series of step by steps execution of this particular tree recursion, and you can look into it. So whatever I have explained, that just represented in, that was the same thing represented in the pictorial format with the explanation why it will come like that. So you just need to take a look into that, and if you have any queries, just drop me a mail. So I have given a reference as well, you can take and read that material, then you will understand why it will be like that. Got it?
So tree and trace are both same.
No, tree and trees, so tree is, so this is not, I am not explaining about trees. So trees are a, tree is a kind of data structure. So what I am saying is that whenever you call a recursion uh, more than one time in the same function, so it will create a, it will execute the program in such a way that it will look like a tree. So that's why it is called as tree recursion. So it has nothing to do with the data structure tree. Got it?
Sir, would it be coming in data structure would be coming their tree data structure in
Eh,
exam?
no, it will not come. So I am just explaining you to understand that what happens if you have a recursion multiple times in the program. Got it?
Hmm. Sir, that before Lagrangian, is there any proof also that could be coming?
So I don't think so. I am not the exam paper. I am not going to set the exam paper. I am just here to.
No, sir, I was not asking question papers question. I was asking like that in our syllabus, is there any proof of Lagrangian?
No, it is not about Lagrangian. You just need to understand the concept, and then sir might ask you. So during the quiz, you will get to know what kind of questions that will be there. Don't worry.
Yes, sir.
Okay. So now we will jump into another thing called structures. So I think I would like to cover most of the material in this pre-final class, so that I want to take the final class bit lightly. So now I will cover the structures and unions as well in the same class, and next class we will be looking into some memory, dynamic memory allocation kind of stuff. So basic idea of structure is, integer, float, strings, and multi-dimensional arrays and multi-dimensional arrays. What is the, what happens if you try to, let's say if the user requirement in such a way that I want one int, one float, and one string together. So I want to represent a data, different data types together. So is there any way that we can do that? So answer is yes. So in order to do that, C compilers will allow you to do such a kind of thing with a special user defined data types called structure. So to define structure, you need to call a keyword. You need to use a keyword called struct, and with a structure, and after struct, you need to give the name of the structure, and you need to define the members over here. So integer a, float b, and string c or something. So those things will be clubbed together. So struct statement will define the new data type and one or more equal to the member. So it will allocate the memory individually to the each member, and it will club all those things together as a structure. So for example, I think I would like to show an example here. So let us assume this is a structure, struct car. So I want to have three variables in this structure. So which is brand, model, and year. So then in the main program, so you need to define the structure before the main. So I want to make it as a global. So then in the main program, you can create a structure like this. So you can see these are two string variables and integer variable clubbed together. So whenever we use this structure, struct car1, so then you can assign the values to that particular structure. So this is called definition and defining the structure together, just like how we do in arrays. So there are two kinds of representation, initialization of the structure. So one is this one, struct with members, and another one is struct with members, and you can define the variable type here. So if you can define the variable structure here, so that can be used later in the program. So I just did the same thing. So here in the main program, I have created three structures of the car type with three different values, and I have created another structure here that is called as cars. So I just try to copy from this structure car1 to this cars, and I try to print all the values together. So this is very fundamental and basic program. So if you want to access the member of a structure, you just need to use it with dot. So car1 dot brand, car2 dot model, and car3 dot year. So something like that. So you just need to use the dot operator before the variable type to access that particular member of a structure. Okay. Let me try to run this program. Hyphen o.
Sir, we are on the tree page.
What?
Your screen Charan board is showing the tree function page, recursion page.
Oh, I see. You are not able to see the screen. I am able.
Yes, multiple times in the Lagrangian when you switch to tree also.
Oh, is it? Let me stop. I think. Is it same for everyone? I don't see here. In my machine it is showing correctly. So are you not able to see this? Um, now it is okay, right? Okay, right? So okay, cool. So don't see that one. We can just see my Venkata Sai Charan. Don't see Charan board. So Charan board is another thing in which I try to show the demonstration. Just see Venkata Sai Charan. You will be able to see the screen. Everybody is okay, right? Shall we go ahead?
Yes, sir.
Okay, okay. So uh, strect. So dot slash. So you can see BMW X5 1999 and Ford Mustang 1969. So here I try to copy structure from one structure variable from here to here. So you can see that cars is having the same data which is car 1 is having, because I copied the value, just like how we assign one value to another variable, like that I just assigned. So all the corresponding values in that thing will also be assigned to that particular structure. So this is simple structure thing. And another thing I would like to show is union. So we have seen structure how we can group multiple things together. So union also does the same thing, but only the subtle difference between structure and union is that only one member can contain a value at any given time. So the reason why here it is that unions are trying to provide an efficient way to use the same memory location for multiple purpose. So if you define a structure, let's say inside this structure if you assign integer char a, char model, and integer year. So char is having 4 bytes. Let us assume it's a 4 bytes, 4 bytes plus 4 bytes, so which will be 12 bytes. But in union it won't happen like that. So whatever is the maximum value of this type, so let us consider, so let's say char and float. So float is having the highest memory allocation, right? So it will assign only that much memory to the whole union, and so you can access multiple values through the same memory location. So I think it will be better you see this example. Let us consider this example. I have defined an union here, and which is having integer I, a float f, and character str. So this is having str is character type and it is an array. So 20 bytes will be allocated to this one. So this is the maximum size of the union. So this is the size that got allocated to the union. But whereas if you define the same thing with structure, you can see that 20 plus 4 plus 4 or 20 plus 8 plus 4, so that is equal to 32. So the 32 bytes will be allocated to the structure, but whereas for the union, whatever is the highest data type, so that much memory is allocated to the union. So that is the subtle difference between structure and union. So let us try to run this example to see what is the memory that occupied by the structure. Let us see clang union. You can see, so although it is 20 bytes of string is having 20, and then float for 8 and 4, 32 should be the ideal size if it is a structure, but union you will just get only 20 bytes. So is there any problems with the union? So for that we will look into this one. So initially we assign a value, we declare a union, and you try to assign a values to the union. So initially in data of I equal to 10, data of f equal to 220.5, and you copied the string program C programming into the str. So ideally it have all these things, but when you try to access the data, C lang union 2.c. So you can see all the garbage value, because these structure can hold a value at a particular moment, so it can't hold multiple values together, because we have assigned only the one value, one memory to the whole union, right? So that's why initially the data will be, data of I will be there, and it will be overridden by 20.5, and finally it C programming was copied to here. So whatever the data it is holding is just C programming language, so all other things will be garbage values, because that will be overridden. So at a time it can only handle one value at a particular moment. So if you try to print the data, you will be having dump values in all the remaining variables and values, and only in the latest one you will get to see the data. So that is what I try to mention here. So only one member can contain a value at a given time. So although unions provides a way to see the thing, but it is not useful. So the ideal way of using the unions is like this. So you define the variable, you assign some value it, then use it, then it will be clear. You write another value to that particular thing, then use it, and you try to copy the other value. So if you try to use the unions in this way, union 3.c hyphen o u3 dot slash u3, so you can see all the values, because at a particular moment union can hold only one value. Okay, so this is the subtle difference between structure and union. So we use struct keyword to define the structure and union keyword to define the union. So this is the key important thing. When a variable is associated with a structure, the compiler allocates the memory for each member, so the size of the structure is greater than or equal to the sum of the sizes of its members. But when it comes to the union, the compiler allocates the memory considering the size of the largest memory. So in the previous case, which was the string array of size 20, so that will be having 20 bytes. So all these things, the size of the union is equal to size of the largest member. So each member within a structure is assigned a unique storage area to the unique storage area, whereas in the union, so only one individual member which is of largest will be having a memory allocation, and all the values will be copied through that particular memory location. That's why we can see the errors, and when we overwrite the values we can't see the previous values, and you can access at only one time. So altering the values of members will not affect the other values, whereas in the unions, because we are using the same memory locations, when you try to alter it, you will see the other values overridden, or you can see the garbage values. So because it is accessing through one single memory location, so individual members can be accessed at a time, but only one member is accessed at a time. So several members of a structure can be initialized at once, and only one member can be initialized at once. So this is the subtle difference between structure and union. So I think you need to understand that this is the founding blocks for thing where we can try to group the several variables or several data types together for larger use case. So let's say if you want to create a schema kind of thing where you want to enter multiple data of a single entity. So let's say if you have an employee name, employee number, employee salary, and employee age, and employee ID card number, and all these stuff together, bundle it together, and structures are the one effective way that you can represent the data in C programming language. So that is all about structures and unions, and the subtle difference between structures and unions. So now we will try to jump into the quiz. So it is getting delayed. So okay, so let's start. Okay, let me stop presenting here, and I will try to share the tab. Yeah, so what are you guys, before jumping into the quiz, do you have any questions regarding the structures and unions? Okay, I think okay, Arshad, we can take the question, no issues. We will take the question. You can ask, or towards the end you can ask. I think it's not allowed, I guess. So because if the function is also allowed, so it will be you are talking about a class. So I mean, this is the low level structures and unions are low level, but if you want to access the function together in between the variables, so you are talking about object oriented programming language. So structures and unions are the basic functions that drives towards the object oriented programming language, where in other programming language like Python and Java, where we club data and methods together in a class. So that is called as class. When you initialize the class, you will be having an object. By using that object, you can access the data in the class and the functions in the class. So you can do that in functions. You can do that in object oriented programming language. As far as my knowledge, I think it is not allowed in C programming language. Dr. Karthikeyan and Arshad. Okay. Anyway, let us take this quiz. So this is simple. So what will be the output of this? Not output. So what is the correct match? What is the right answer? Okay. 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 A is the right answer because trapezoidal method is used for integration, and Lagrangian is used for interpolation, and Newton method is for uh, root finding, and Ranjikutta method is used for differential equation. So option A is the right answer. So let's go to, yeah. So I think Tushar, somebody has asked, so how do we need to learn this interpolation in a mathematical way? So this is a sample question. You might expect such a kind of question. So here they have given x naught, x1 and x2, and they are asking, they are giving f of x1, f of x2 and f of x3. So they are asking you to find the Lagrangian for L1 at when the x equal to 18. So you just need to take the pen and paper and try to answer this question. I will give 2 minutes. By this time you would have known the equation, Arshad. Okay, okay, cool, no issues. Okay, so here they are asking about just L1 value at x equal to 18. So you don't need to calculate L1 into 5.2, just calculate L1 value, which is x minus something by something plus into x minus something by something. So if it is L1, you need to ignore 2 and do the calculation with remaining terms. So that is the equation will be like oh, what is the equation? So the equation eventually will be like x minus 10 by 15 minus 10 into x minus 20 by 15 minus 20. So from the equations that I have got, so if you substitute 18 here, so 18 minus 10, okay, should I think it's better that I solve it here. Is anybody is doing, or should I write the answer? Should I try to solve this thing? Sirisha and Varshini, are you trying to solve yourself?
Wait, sir, I am doing now.
Okay. 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 I will give you another 1-2 minutes. Don't worry. You solve it and then. Okay. Okay. You can do it later. I think I will solve it. So maybe some other guys are also trying to answer. So if anybody is trying, just let me know. Otherwise, I will try to solve. Anyway, let us see. So we are trying to solve what?
Sir, I am also doing. Please wait.
Okay. Okay. Cool. We just need to find L1 of x. Okay. Okay. I think I have shared it here, so you can see. So x0, x1, x2 will be there, and f of x0, x1, x2 will be there. So what will be the L1 of x and x equal to 18? That is the question. So let us try to solve this one. So Lagrangian of x1 is, so options. So you want options? Options is 0.64, 3.33, 2.67, and 0.56. 0.64, 3.33, 2.67, 0.56. Anyway, I will try to solve it. So x1, so x minus x naught, I am trying to directly answer. So x minus 10 by x1 minus x naught, so 15 minus 10 into x minus x2, x minus 20 by 15 minus 20. Okay, so x minus 10 by 5 into x minus 20 by minus 5. So when I am writing the answer here, so x minus 10 by 5 into x minus 20 by minus 5, which is equal to, if x equal to 18, 18 minus 10, 8 by 5 into minus 2 by minus 5, so 16 by 25, 64. Option A is the right answer.
So mine is 3.328.
Why it is 3.328? The answer is, as we discussed, it is 0.64. Okay,
Okay.
so yeah, so let us try to answer the third question. Answer is 0.64, Dr. E. Karthikeyan. So it is 0.64, option A. So now we will look into the third question. So to solve the differential equations, okay, Sirisha is saying it's D. Why? Can you unmute yourself and tell other people also why it is D? Is there anybody who would like to answer? Okay, the answer is D, because you need all the differential equation dy by dx in the form of x and y. You need all the three, so you need to have the step and number of step.
Hello.
Yeah,
We get 0.64 when we did not multiply 5.2.
that's what I am saying. So you don't need to multiply 5.2. They are just asking L1 of x. You need to read question carefully.
Oh. Sorry. Thank you, sir.
Uh, so 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 the option is D for the third question, because you need all the values, all the options. So the initial value of y you need to have, and the step based on which the iterations are executed. And you can go through Professor Basu's class again to revise this question. So I tried to, because I tried to pack all these things together. That's why I didn't cover Ranjit Kutta method in this class. So but you can revise the class and go to the lecture again to understand it. So I think you should be able to answer this question. I am expecting everybody to answer this question at least. Given two data points, a mean x naught and f of x naught, x1 and f of x2. So Lagrangian polynomial that passes through these 2 points is what? We have discussed this thing for more than 20 minutes. I think you should be able to answer this question right. Okay. Yeah. Varshini is saying it's A. Cool. Okay. Chandu is saying it's D. Can anybody who would like to answer? Okay. Uh, Chandu, can you try to unmute yourself and answer why it is D?
Sir,
Yeah.
that's based on formula, sir.
Okay. Yeah. So what is the wrong with A? At least tell me that thing.
In the A option, after place x minus a by a minus b, sir. That's wrong, sir.
Okay, cool. So it should be B minus A, right? So
Yeah,
yeah. Nice.
there is a change in last part.
Yeah. Anyway, so this is the last question. So I think you guys know this question. So what is interpolation is a process for what? Okay.
B.
Yeah.
B.
B is the right answer because the interpolation, as we discussed in the class, so we are trying to find out a value between 2 points on a line or curve. Okay, so I think that's all for today's class. I will try to paste this code snippets into the uh, class notes, and I will try to upload it by this end of the day. So that's all for today's class. I think we have covered a lot today. So we try to initially understand what is Lagrangian, and then we looked into that program, and then we try to understand how do we perform integration based on trapezoidal rule, and then we saw how this thing will be varied. The error will be reduced when you take more number of trapezoids. When you divide the space with multiple trapezoids, you will reduce the error. So we have seen that through programming, and then we learned about linear recursion and the tree based recursion. So I highly suggest everybody to look back into this video for tree recursion and solve it with when the x equal to 4. So and then we looked into the structures and unions and what is the subtle difference between the structures and unions. So that's all for today's class. I think hopefully we will meet in the final class on next week. So if,
So my question.
what is your question?
So I am saying when we find the Lagrange equation for the variable,
Okay.
it come out 6x square minus 11x plus 6.
Okay.
And this equation give always a positive curve.
Okay.
But x cube also give a negative curve with the value less than a 0. How this will justify?
No. The thing is, we are the interpolation, right? So interpolation, we are trying to find the values in between two. We have given 3 points, and we are trying to find out the points, find out the curve in which fits the 3 points. And interpolation is like you are trying to find out a point f of x cap which is there in between any 2 points. So when you try to find out a curve which is there in somewhere in the negative quadrant, so the curve will be different. If you have x1, f of x1, and x naught and f of x naught is different, you will get different curve. You got it? Because for these three values you got that curve.
Okay,
Got it?
okay.
Okay. So that's all for today's class. I think hopefully we'll meet in the next class, which is a final class of our tutorial session. So have a great evening. Thank you. Good night.
Thank you, sir.
Actually, sir. Sir,
Yeah.
sir, I was asking that the next class would be final class.
Yeah. Obviously, this is the 12th week, man. So this is the next class will be the final class.
No, sir, I know that, but that we are not able to attend the Saturday session. So could you take one or two more extra classes so pertaining to doubts of anyone who could not attend any मतलब बस कोई भी क्लास अगर किसी की छूट गई हो या फिर लाइक दैट या फिर कुछ
No,
डाउट
Tushar. So the thing is, we are officially allocated to take classes this till this week. So after that, we are not supposed to. I mean, this is not in control of our hands. So this is organized by PMRF in with respect to NPTL. So they have to decide that whether they have to extend this one or two classes, because that is
Sir,
not.
I'm not saying on this portal you can take on YouTube live stream also that they would not be able to question.
Yeah, I can take, but the thing is, I am running a bit, tight. So I have some other submissions as well, and I'm working on some thing which is
Sir,
going on.
if you are not able to take after the next class, so you can take in between this week also.
Yeah, by anyway you can drop me a mail. So if you have any questions, so I mean, these are large audience, right? Everybody have different questions. So I can't specifically target set of things. So if you have any queries, you just drop me a mail. I will try to respond you. So that might work better than taking a class and calling all people together. So this is a, they have some other things to do, right? So it is better you just drop me a mail, and I will make sure that I will respond within a day.
Sir,
Okay.
that is okay, but I was saying for all like that, who wants to join, who have any doubt that can person can join, that doesn't have any doubt that need not to join. That would not be like that.
Yeah.
And I was saying that I can mail you, but I have better understanding in physical class, but that is not possible. So only option is like meeting. So if possible, because you are running tight after this week, so you can take in this week if possible.
I will think about it, but I'm not really sure about that because I'm TA for this class, and I have other duties in college and
Yes,
then
sir,
other
I
things.
understand. That's why I said if possible,
So
if you are
you
not
you
able
you may not
to.
understand this. For making this presentation, I have to sacrifice 2 days of my week to sit and make notes and take the all this preparing the questions and preparing the programs, and I need to re-verify it for another time and all this stuff. But anyhow, I will try to look into it. I'm not really sure, and I can't guarantee you right away, but I will try to see.
I totally understand that. No worries. If possible, you can take. Otherwise, I will drop mail surely.
Yeah,
And
sure.
if I am not able to understand, for that I was saying, if I am able to understand that not need, if possible, then you can take. If not, so I totally understand your scenario.
Okay.
So possible
Okay.
you can.
Okay.
No burden on you.
Okay. Thank you, Tushar. I will try to rethink about it. Thank you.
No
Okay.
Hello,
problem.
Okay. Bye. Have a great day.
hello, hello. So,
Yeah, Arshad.
can I ask a question outside of the syllabus?
Yeah, you can drop me a mail. I can answer. No issues.
Just for a just for a second.
No. I have to go somewhere, so I'm getting
Oh,
late. So
okay.
sorry. I will
Also, we
take.
can do and like that in the next class we can take it for a long time so that all queries are answered, so you will not have any problem to reschedule any class, to schedule any class furthermore.
I will see. I will see. I'm not really sure because we will
No
try to
problem.
do that, but I am not really sure how much time because I have to make this room available for some.
Sir,
There are
just
so many
that I
constraints, man. So I can't explain everything here. So I will tell you. Don't worry.
no problem, sir. If you, I am not pressurizing you. If you are available, then only it
Sure,
is totally up to you, sir.
sure.
So,
Okay.
what is your thesis?
Huh?
Thank you, sir.
What is your thesis or major?
Who's mine? Thesis? What is thesis? I don't understand your question.
I am saying what is a
Sir, I'm
thesis
saying
or
about doctoral
major?
PhD.
PhD.
Yeah.
So
Yes, sir. Yes, sir.
I am working on cyber security. I'm working on a specific malware called advanced persistent threat. So I'm trying to work on the detection methods of that particular thing.
Okay,
You
okay,
can you can search through the Google Scholar and all these things. You will get to know.
okay, okay, okay.
Yeah. Okay, man. Good.
Because sir, I was
Yes,
saying
sir.
that in previous class, some girl was also saying like me. So you were saying we can take extra class. That's why I said
Okay. I will look into it, man. So
no
don't.
problem, sir.
No, okay.
If you are available, no pressurizing. You can
Yeah.
go, sir. You have other things
But
also. Okay.
as far as now, so you are able to this you are able to understand the things, right? So you don't have
Yes.
any. Okay.
Thank you, sir.
Okay. Okay, man. Fine. Bye. Good night for everyone.